Hello, hello, and welcome to a little video about the Unit 2 test review. Number 1, consider the sequence shown. In letter A, we're going to describe the pattern. What we're going to do here is take a look at the shapes and in English, tell what's happening. Take a second to look and then I'll write it down. Hopefully you notice that each shape has one more side. In letter B, I'd like to write a numeric statement to represent the first 6 figures. Numeric means numbers. So instead of shapes, let's do numbers. I have the 4 first shapes, so I have the first numbers, which means I'll only need to add 2 to the list. Let's start with the shapes. First, I have 3 sides, 4, 5, and 6. So 2 more figures would be 7 and 8 sides. In letter C, I'm asking to determine the number of sides of the 12th figure of the pattern. Well, that means I need 6 more figures after the one I had written in letter B. So 6 more would be 9, 10, 11, 12, 13, 14 sides. Good thing I didn't ask us to draw it, because can you imagine? Oh my god. All right, number 2. Write the first 5 terms of an arithmetic sequence. Ooh, arithmetic means we're adding or subtracting with a common, with a common difference of negative 0.6 and a first term of 0.7. The common difference is our pattern, but it's specifically the pattern for adding/subtracting. Well, we got a first term of 0.7, which means we'll write 0.7 right there. Our common difference is minus 0.6. Well, that means we're subtracting 0.6 over and over and over again. Let's do it. 0.7 minus 0.6 is 0.1. Then we get negative 0.5, and then negative 1.1, and then negative 1.7. Perfect. Be very careful on the test and make sure to read this correctly. What I've seen as common mistakes over the past couple years is starting with negative 0.6 and then adding 0.7. So make sure you're noticing that the first term is 0.7 and then the difference is minus 0.6. Just a little hint based on previous years. For numbers 3 and 4, what we're going to do is decide whether or not these sequences are arithmetic or geometric, and then determine their common difference or common ratio. Like we mentioned in the previous one, common difference is the pattern for the arithmetic sequences, which are sequences that go through adding, subtracting. So that means common ratios is what we call the patterns for geometric sequences when we multiply or divide. Now in number 3, maybe you can tell what's going on. But let's say you can't. I'm going to experiment with the arithmetic sequence. In order to find the common difference of an arithmetic sequence, I'm going to take the second term minus the first term, which is 40. So 5 minus 40 is negative 35. So if this was arithmetic, I would be subtracting 35 every time. Does that work? Hopefully you notice that no, it does not. Because if we do 5 minus 35, it's not 0.65. That doesn't make sense. Well, if it's not arithmetic, then it's geometric. So let's find the common ratio. To find the common ratio, we're going to do something similar to the difference, except instead of subtracting, we're going to divide. 5 divided by 40 is 1/8. Now, maybe you're looking at this and you're like, hey, Gumin, listen. I could tell that to go from 40 to 5, I divide by 8. Why did you write 1/8? Well, you are right. We are dividing by 8. Dividing by 8 and multiplying by 1/8 is the same thing. Just like dividing by 2, multiplying by 1/2. Dividing by 3, multiplying by 1/3. Number 4. Let's test to see if it's arithmetic. If not, then it's geometric. There's only 2 options. Well, if it's arithmetic, it has a common difference, which means we will do second term minus first term. And I get negative 11. So it's telling me if this is arithmetic, I'm subtracting 11 every time to get between one term to the next. Test it out. Does that work? It does. Very good. It's arithmetic, and our common difference is negative 11. In number 5, what we're going to do is we're going to write a sequence. We're going to write a formula using this sequence. We're going to be using the explicit formula. The explicit formula is an equals, which is any term equals, a1, first term, plus d, our common difference, times n minus 1. Now, since this is the formula, we're going to leave an and n minus 1 alone. We're not touching it. We don't know what it is. They stand for the terms we're looking for. We're not looking for anything. All right. Well, first term is 10.3. So that's the first thing I'm going to write down right here. 10.3. Now let's find the common difference. Just like in those previous problems, to find the common difference, we're going to take second term minus first term. And I get negative 7. That means the pattern is subtracting 7. So we got minus 7 and then n minus 1. Fantastic. Number 6. From the following sequence, let's write a recursive formula. Not my favorite formula. No offense, recursive, but let's do it. The recursive formula is an for any term, an minus 1, which means the previous term, plus d, our common difference. Just like in the explicit formula, we're leaving the an and an minus 1 alone. They stand for the terms we're looking for. We're not looking for anything. We're just writing down the formula. So for number 6, I'm just going to start with an minus 1. Now let's find d, our common difference. We're going to do the same thing as before. Second term minus first term. Negative 13 minus negative 24 is positive 11. Since 11 is positive, I'm going to write plus 11. In number 7, what we're going to do is determine the 30th term in the sequence defined by an equals 6 plus 3 n minus 1. What that means is we're going to take 30 and we're going to plug it in to n. Let me move my screen a little bit. There we go. All right. So in order to find a30, I'm going to plug this into my calculator. 6 plus 3 times 30 minus 1. This whole thing, as is, goes into your calculator. And you should get 93. Double check. The most common mistake I see is that students accidentally click a negative sign instead of a minus sign when subtracting 1. Be very careful. It will mess up your answer. All right, last one, number 8. A baby giraffe measures 200 centimeters tall at birth. I absolutely made that up. It is way bigger. Every day thereafter, the baby grows 2 centimeters in size. Represent the height of the baby giraffe in centimeters for the first 5 days using this table of values. Well, if the baby measures 200 centimeters at birth, that's how much it measured at first. First means first term. We're going to put 200 right here. The baby is growing 2 centimeters. That means we are going to be adding 2 over and over again until we fill out this table. I'm going to try to zoom in. There we go. Beautiful. Okay. The second month, the giraffe's going to be 202 centimeters. The third day, my bad, 204, 206, and 208 on the 5th day. Wow. For number letter B, we're going to write the explicit or recursive formula. Now, since I'm giving you the choice, I'll show you both. I personally like the explicit better, but whatever floats your boat. Here's the recursive. an equals an minus 1 plus 2. E. Why do I not like the recursive formula as much? Well, it can only help me find the next term. I prefer the explicit because I can find whatever term I feel like using the explicit. So I could have asked you how big the giraffe is in a year. That's 365 days. Imagine continuing the pattern for 365 numbers. OMG. So, instead, I would have used the explicit. On that note, let's write the explicit. We start with our first term. And then we put our common difference. And then the letters n minus 1. Beautiful. Letter C asks us to predict the height of the baby giraffe in 8 days and explain your reasoning. Now let's say you use the recursive formula. You could continue the pattern and then say, I use the recursive formula. Or you can do what I'm going to do. You're going to take the explicit formula and plug 8 into it. And that's what we'll say. All right, I'm going to do it right here. 200 plus 2 parentheses 8 minus 1. And I'm plugging in 8 because I'm looking for 8 days. Type this into your calculator exactly as is. And while you're doing that, I'm going to write down the explain your reasoning part. Hopefully, the answer that you got was 214 centimeters. The explanation I use is that I use the explicit formula. And then you showing this work plus this English expression is enough to explain my reasoning and show proof for my answer. If you have any questions about what you've seen today or just any part of this unit or whatever you're working on, please let me know or whoever's helping you out with math know. Otherwise, have a wonderful, wonderful rest of whatever day it is for you. Bye!